All right, when we talk about finding all the zeros, guys, what you are doing is you're setting the equation equal to 0 and you're solving. So some things that we need to remember, we need to take into account. Write this down if you need to. When you are finding the zeros, the solutions, the roots, all that stuff, you're finding out what x equals. So the first thing we try to do is we're going to try and factor. All right, we're going to try and factor. When we factor, the first thing we look for is a GCF, correct? The second thing we look for is if it's a trinomial, whether a is 1 or it's not 1, we multiply a times c. Figure out what multiplies to give me the last number, adds to give me the middle number, right? We can look to see if it's the difference of perfect squares, right? That's when we have two terms and there's a minus sign in the middle. If there's 4 terms, what do? If there's 4 terms, we group, right? Everybody with me? All the stuff with factoring. If it's a trinomial and it's a quadratic, meaning your highest exponent is 2, and it doesn't factor pretty, then we use the quadratic formula. But if all else fails, does anybody remember what that last thing is that we do if all else fails? The P over Q. That's where we take the last term, we write out all the factors of it, and we use our synthetic division, okay? You have to be able to look at a problem and know you have to go through that thought process. So let's look at this now, and we'll do these together, okay? If I look at number 18, the first thing it says to do is we're solving. So that means I want to say, okay, x squared plus 10x plus 23 equals 0, right? First thing we look for is a GCF. Is there a GCF here? No. How many answers should I have for this problem? 2. How do you know that? Because it's squared. Good. So this is a trinomial. We say a times c. 1, that's the number in front of x squared, times 23. Well, what are the factors of 23 that'll multiply to give me 23 but add to give me 10? None. Right? 1 and 23, that would give me 24. That's not going to work. So, guys, if it's a trinomial, that's a quadratic, and it doesn't factor, what do we use? The quadratic formula. So a is 1, b is 10, and c is 23. Right? Quadratic formula. My quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a, right? So let's fill in. I have negative 10 plus or minus 10 squared minus 4 times 1 times 23. And I divide that by 2 times 1. Questions? Okay, let's just simplify. Negative 10 plus or minus. What is 10 squared? 100. Minus, what's 4 times 23? 92. All over 2 times 1 is 2. Questions? Simplify a little more. Negative 10 plus or minus. What is 100 minus 92? 8 over 2. Now looking right here, guys, are my solutions going to be real or imaginary? Yes, they are real. Is it going to be nice, pretty, even whole numbers? No. But it is going to be real. How can I look at this from this point right now and say, oh, I have 2 real answers? Yep, the discriminant. Look underneath your square root. Is that a positive or a negative number? It's positive. That means it's going to be real. What can I break 8 into? 4 times 2. We use 4 and 2 because 4 is a perfect square. Right? So what is the square root of 4? 2. That comes out in front. So I have negative 10 plus or minus 2 root 2 over 2. Can I simplify that a little more? Yes. 2 goes into negative 10. I have negative 5. And then 2 goes into 2 once. So plus or minus the square root of 2. And there are my 2 answers. Are they pretty? No. But those 2 specific spots on the x-axis at negative 5 plus root 2 and at negative 5 minus root 2. All right. Scooting along, scooting along, scooting along. Number 20. Number 20 is going to be the exact same thing. You guys are going to have to use the quadratic formula. We'll skip that one, come back to it at the end if we have some time. But there's no factors of 2 that'll multiply to give you 2 and add to give you 6. So you'd have to use quadratic formula here. So let's look at 22. All right, we're trying to find all the zeros. So we say x squared plus 36 equals 0. This one's a little different. How is this one different? Well, let's go through the process. Is there a GCF? No. Is this a trinomial? No. Is this the difference of perfect squares? No. If that was a minus sign, we'd be in business, but it's not. So can I solve this? Is there anything I could do? Okay, I see 2 perfect squares. Can I just move the 36 to the other side? Right, so it becomes x squared equals negative 36. Agreed? How do you solve x squared? Take the square root. If I physically put the square root on something, what goes in front of my answer? Okay, plus or minus. So think about this, guys. This is 36 times negative 1. What is the square root of 36? 6. And then what's the square root of negative 1? I. So there are my 2 solutions. They just happen to be what kind of solutions? Imaginary. If you guys left it as plus or minus 6, I'd take off a whole bunch of points because there's a huge difference between real numbers and imaginary ones. All right, on 26, go ahead and make this one change for me. Make this a plus 3 here. Everybody change it to plus 3. All right, now we go through. I have x squared minus 4x plus 3 equals 0. We're finding the zeros. Is there a GCF? No. Is this a trinomial that I can factor pretty? No. Well, now it is since I changed the plus sign. What are the factors of positive 3 that'll multiply to give me positive 3 but add to give me negative 4? X minus 3 and x minus 1. Negative 3 times negative 1 is positive 3. Negative 3 plus negative 1 is negative 4. So now, guys, can you clearly see the 2 solutions? Yes. Yep. You set each one equal to 0. You got x equals 3 and x equals 1. Both of those solutions are what kind of solutions? They're both real. Good. All right, let's look at 24. Same thing. We're trying to solve. We're trying to find the solution. So I have 81 y to the 4th minus 625 equals 0. Go through the motions. Is there a GCF? No. Is this a trinomial that I can factor pretty? No. Is this a quadratic that I could just use the quadratic formula? No. I like that we're seeing, you guys are telling me difference of perfect squares. I like that you're thinking that. It's not a perfect square, but you're on the right track. What can I do with that negative 625? Okay, I can move it to the other side. I have 81 y to the 4th equals 625. I'm trying to get y all by itself. So what do? Divide both sides by 81. So I have y to the 4th equals 625 divided by 81. Does that divide nice and pretty? No. So how do I get y all by itself? I'm not going to take the square root. I'm going to take the what? The 4th root. Good. I'm going to take the 4th root. What kind of a number is 4? Even or odd? So if I take an even root, what goes in front of my answer? Plus or minus. So plus or minus. 4th root means what number times itself 4 times gives you that number? So think, what about 81? What number times itself 4 times to give you 81? 3. Yep. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. What about 625?
6.
Not 6. 5. 5 times 5 is?
25.
Times 5 is? 125. Times 5 is? 625. You're close. It's cool. You're all right. It's fine. I totally understand. I'm with you. All right, scooting along. Let's go to 28. Okay, this says x to the 4th plus 29x squared plus 100 equals 0. We're trying to solve, try to find the zeros. GCF. No, okay. Is this a trinomial that I can factor?
No.
It is. It actually is. If you guys didn't see that, could you use the quadratic formula? No. Why not? Because it's to the fourth power. Quadratic formula can only use if the highest exponent is 2. But let's look at this for a second, guys. If I break this down, good job. What times what gives me x to the fourth? X squared and x squared. What times what will give me 100 when I multiply, but 29 when I add? 25 and positive 4. Perfect. Can I factor those more? Can I break that down anymore? No. Why not? Because it's positive. If it was minus, yes, different to perfect squares, but it's not. So what can I do? I have to just solve. I can say x squared plus 25 equals 0, and x squared plus 4 equals 0. So when I move 25 over, it becomes what? Negative. When I move 4 over, it becomes what? Perfect. Now what do we do it from this point? Take the square root. When I physically take the square root, what goes in front of my answer? Plus or minus. Now think about this, guys. I have the square root of negative 25. What kind of a square root am I going to have here? Imaginary. Square root of 25 is 5. The square root of negative 1 is I. So I have plus or minus 5i here. What's the other side? Good. Plus or minus 2i. How many solutions do I have? 4. How many did I know from the beginning I should have? Good. Very good. All right, 32. Here we go. Again, we're solving. So we're going to rewrite the problem and say x cubed plus 11x squared plus 39x plus 29 equals 0. Yes? First thing we look for is a GCF. Is there any number or letter that I can take out of all 4? All right, so now if I have 4 terms, what do we look to do if we have 4 terms? We look to group. So first 2, second 2. What can I take out of the first set of parentheses? So I have x squared. I'm left with x plus 11. Can I take anything out of the next set of parentheses that will leave me with x plus 11? So then grouping doesn't work. If nothing works, what do? P over Q. You take the factors of the last number. Guys, before you start yelling at me and getting mad, there's only 2 factors of 29. It's 1 and 29. We have to account for positive and negative. You take the last term, you write out all the factors, you have to account for the positives and the negatives. So now we try our synthetic division. I personally always start with 1. Do what you want. If you don't want to, you start with whatever, but I just always start with 1. Where am I getting these numbers from? 1, 11, 39, 29. From the equation. Okay, so synthetic division, we bring down the first term. You multiply to the corner. 1 times 1 is 11 and 1 is 12. 12 times 1 is 12. 39 and 12 is this going to work? Okay, so just stop. Try negative 1. So 1, 11, 39, 29. Bring down the 1. What's 1 times negative 1? What's 11 minus 1? 10. 10 times negative 1. 39 minus 10. Okay, so now 29 times negative 1 is negative 29. Ooh, 29 and negative 29 is? 0. So what did you guys just prove to me? Negative 1 works. Negative 1 is a factor. So x equals negative 1. That's one of my zeros. How many should I have? 3. So this is my resulting polynomial. We should remember this. This is my remainder, my constant, x, and x squared. So my resulting polynomial is x squared plus 10x plus 29 equals 0. So now we go through the whole process again. GCF? No. Trinomial? Yes. Can I factor it? Are there factors of 29 that'll multiply to give me 29 but add to give me 10? Oh, so what do we have to do? Quadratic formula. A equals 1, B equals 10, C equals 29.
Could you repeat the synthetic division? Is that like, could you do that?
Yep.
Instead of doing quadratic formula, could you do synthetic division?
Yes, but it won't work because that'll give you what'll happen here is it won't work and it'll just prove to you that there's no real zeros because these end up being imaginary. So I have negative 10, good thinking though, Pablo. 10 squared minus 4 times 1 times 29 all over 2 times 1. So I have negative 10 plus or minus. What is 10 squared? 100 minus 29 times 4. 116 divided by 2. Well, what do you notice, guys? It's going to be imaginary. So I have negative 10 plus or minus. 100 minus 116 is negative 16 over 2. Everybody see that? So I can do a little more simplifying. What is the square root of negative 16? This is going to be 4i, right? So can I divide 2 into negative 10 and into 4i? All right, so it's going to be negative 5 plus or minus 2i. So Pablo just asked a really good question. Pablo said at this point here, right here, can I just do synthetic division again? And if you did, you would come out that you would try 1, negative 1, and you would try 29 and negative 29, and none of them would work. So it does, in a sense, work to say that to find the real zeros because these two are not real. But if it's asking you to just find all the zeros, then it would be incomplete. So what happens is if they ask you to find all the real zeros, so that in that case, Pablo, it would have worked because you have one real zero. But they're asking you to find all the zeros. So synthetic division won't help you find the imaginary ones. Good question, though. All right, couple more. Here we go. 3x cubed minus 2x squared plus 75x minus 50 equals 0. First thing we look for is GCF. Is there one? Nope. So now I look and I say, well, I have 4 terms. What happens with 4 terms? You group. Very good, guys. What can I take out of 3x cubed and 2x squared? X squared. And I'm left with 3x minus 2, right? My second parenthesis should look like what? 3x minus 2. So what can I take out of 75 and negative 50? Bigger. 25, positive, right? And I'm left with 3x minus 2. So my new GCF is what? 3x minus 2. We write that one time. And then the leftovers get their own parenthesis, right? So x squared plus 25. Can I break down x squared plus 25? No. If it was x squared minus 25? Yes, but it's not. It's plus. So now I just take each piece and I set it equal to 0. So 3x minus 2 equals 0. X squared plus 25 equals 0. So when we move 2 over, it becomes positive. So you have 3x equals 2. Divide both sides by 3, right? X equals 2/3. Move 25 over, it becomes negative. Excuse me. So when I take the square root, what goes in front of my answer? Plus or minus. And what is the square root of negative 25? 5i. So again, we have 3 solutions here. One of them is real, and the other 2 are imaginary. Or as Gio said last period, fake. Okay, so I have x to the 4th plus 6x cubed plus 10x squared plus 6x plus 9 equals 0. And you guys are like, oh my goodness, Miss Meadows, it's the first day back. Hit the ground running, right? First thing we look for is GCF. Is there one? No. Is this a trinomial? No. Can I use the quadratic formula? No. Can I group it? No. When all else fails, what do we do? So I take that last term of 9, and I say, what times what gives me 9? So 1, 3, and 9, plus or minus. And we have to use what? Synthetic division. So 1, 6, 10, 6, and 9. Bring down the 1. 1 times 1 is 1. 6 plus 1 is 7 times 1 is 10 and 7 is this going to work? No, right? This becomes 17, 20. This ain't going to work. Go to negative 1. 1, 6, 10, 6, and 9. What's 1 times negative 1? Negative 1. 6 minus 1 is 5. 5 times negative 1 is negative 5. 10 minus 5 is 5. 5 and negative 1 is negative 5. 6 minus 5 is what? Is this going to work?
No.
Okay. So try what?
Negative 3.
Okay. I'm going to try positive. I always go positive, then negative. If you want to try negative, go ahead. But 1, 6, 10, 6, and 9. 1 times 3 is 3. 6 plus 3 is 9. 9 times 3 is, what is it? Okay, 10 and 27 is, wait, is this going to work? Ay, ay, ay. Now I go to negative 3. 1, 6, 10, 6, and 9. 1 times negative 3 is negative 3. 6 minus 3 is 3. 3 times negative 3 is negative 9. 10 minus 9 is 1. 1 times negative 3, negative 3. 6 minus 3 is 3. 3 times negative 3 is, and negative 9 and positive 9 is 0. So what did you guys just prove? That it works. X equals negative 3. Well, how many answers should I have? I should have 4. So this is x cubed, x squared, x, a constant. So my resulting polynomial here, what I have left over is x cubed plus 3x squared plus x plus 3 equals 0. So now we go through the whole process again. First thing I look for is a GCF. Is there a GCF? No. But there's 4 terms. What do I do with 4 terms? We group. So let's group first 2 and the second 2. I can take out an x squared, and I'm left with x plus 3, correct? Can I take anything out of the second parenthesis? I could take out a 1. Because I wanted to say x plus 3, which it already does. So I'm just going to take out a positive 1. I don't need the signs to change or anything. So my new GCF here is x plus 3. And then the leftovers get their own parentheses. So it's x squared plus 1 equals 0. Can I break down x squared plus 1 anymore? No. That is not the difference of perfect squares. So at this point, we just say, okay, x plus 3 equals 0. X squared plus 1 equals 0. When I move 3 to the other side, it becomes x equals negative 3, correct? And then when I move positive 1 over, this becomes x squared equals negative 1. Take the square root. What goes in front of my answer? Plus or minus. What's the square root of negative 1?
I.
Just I. So there's our 4 answers. 2 of them are real. 2 of them are imaginary. All right, want me to go back up to 22? Let's look at 22. 22 here. Yeah, no problem. And then we can go over to 20. Is 20 going to work out nice and pretty? No, there's no GCF. There's no factors of negative 2 that'll multiply to give me negative 2 and add to give me 6. We're going to have to use the quadratic formula. So A equals 1, B equals 6, and C equals negative 2. You guys with me? So quadratic formula is going to be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 2 all over 2 times 1. So we have negative 6 plus or minus, what's 6 squared? And then what's 4? Negative 4 times negative 2. Positive 8, good. Over 2. So I have negative 6 plus or minus. What's 36 and 8? 44. All right, over 2. Am I going to have real solutions here or imaginary? Look underneath the square root. Is it positive or negative? It's positive, so they're going to be real. So I'm going to break down 44. What times what is 44? 4 times 11, right? Well, what's the square root of 4? 2. So this is the same as negative 6 plus or minus 2 root 11 over 2. And can I simplify that? Yep. Yes. 2 goes into negative 6, negative 3. And 2 goes into 2 once, so you have plus or minus the square root of 11. If you want to put a 1 in front of that square root, you're more than welcome to. But if you have a quadratic, meaning the highest exponent is 2, you can always use the quadratic formula.